Right, so this is exercise 1704, and we're going to look at the first question. So we're told here that we'll highlight what we've got. We've got a velocity statement right there, and it's about an object passing a point P. The first question is, when will the object come to rest? All right, so let's answer that to begin with. And then obviously that is when v is equal to 0. All right, so not all of the questions are going to require differentiation or integration, and this one doesn't, because when it comes to rest, v is just equal to 0. So we set the velocity statement to 0, and this is a nuisance. Here we go, we've got back now. So that's 12t minus 3t squared. We can take a factor of 3t out of that, which leaves us 4 minus t. And when that's equal to 0, when t is equal to 0, and 4, just by solving the equation as we would normally do. So that's A. Next question then, if we will highlight, I'll choose another color to keep it interesting, is what is the acceleration after 5 seconds? Okay, so let's look at that then. So acceleration, and it's always handy just to have this document here, not that one, this little diagram here. Get rid of that. Oh wait, oh, no, wrong thing. We'll get there. So we've got S, V, A, and remember we differentiate down and we anti-differentiate back up. So I've got a velocity statement and I want an acceleration statement. So you can see there that I'm going down, so therefore we differentiate down. So let's do that over here. I've got v is equal to 12t minus 3t squared. So therefore the acceleration, if we differentiate that, becomes 12 minus 6t. Okay, so hopefully you're remembering how to differentiate. There's the statement. And then it says, what is the acceleration after 5 seconds? So we just substitute 5 into the equation, and that becomes 6 minus 30. Then we put that 5 in, 6 5s are 30. And I've got an acceleration of negative 18 meters per second square. Now, the next part of the question says, give an interpretation for this acceleration. So you can see the acceleration is negative 18, so that negative is significant, and that means that it is decelerating. Okay, the object is slowing down. If the acceleration is positive, that would mean it's speeding up, but here it's negative, therefore it's slowing down. All right, next part of the question has got how far is P? How far from P is the object? Okay, so how far after 7 seconds? So I'll answer that over on the right here. So a far question is to do with distance. Now I'm given the velocity and I've got that. So you can see if I'm going from velocity to distance here, I need to anti-differentiate. We go back up. All right, so here's the first questions that we dealt with where we're dealing with differentiation and anti-differentiation. Right, so again, we start with the velocity statement. So velocity is equal to 12t minus 3t squared. We anti-differentiate to get s. So now I add to the power, divide by that power, minus 3t cubed. So we add 1 to the power, divide by that power, and this time, of course, we add c, the constant of integration. So tidying that up, I get 6t squared, those 3's cancelled, minus t cubed plus c. All right, so we do need to have a reread of it to work out if we've got enough information to calculate c. So we're going to do that. An object moves in a straight line, so that its velocity and time in t seconds since the object passed point P. So we're assuming that the object at point P, that's when time is equal to 0. And if it's at point P and we're measuring from point P, then the distance is equal to 0. So therefore I've got T equals 0 and I've got S is equal to 0. And if that's the case, then C is also equal to 0. Hopefully you can see that, put all the zeros in, we've got that. So therefore S is equal to 6t squared minus t cubed. And that is the expression now for the distance. And the last thing to do is to substitute 7 into that. So 6 times 7 squared minus 7 cubed. And we'll work that out on the calculator. 6 times 49 minus 7 to the power of 3. And the answer there, S, is equal to negative 49. So if the object was initially moving to the right, it's now 49 meters in the opposite direction because of that negative state.